here we have a problem where you're given some information and you're asked to calculate the specific heat of copper in units of joules per gram degree Celsius, and you're giving a Q, a amount of thermal energy in kilojoules. You're given a mass of copper, and you're giving initial and final temperatures. So this time you're still using the same equation that you used in the previous problem there, the other specific heat problem. Only now you're solving it for C instead. So to do that, you just rearrange your equation, to solve for specific heat instead of Q. So you divide both sides by m delta T, and you'll be able to, isolate the variable C, specific heat. Now, when you look at your units up here, you're asked to come out with in joules per gram degrees Celsius. So you have temperature in degrees Celsius. You got mass, though, right here in kilograms. So that's going to need to be converted. And you've got energy here in kilojoules, not joules. So you need to make those conversions. So 34.0 kilojoules. Remember, 1 kilo anything is 1,000 of those things. So you're really going to multiply it by 1,000. It's 3 significant figures. So you could write it as 3.40 times 10 to the 4th joules, or you could just understand that it's 34,000, but it only has 3 sig figs. And I don't care which one you use, as long as you keep track of your sig figs, it's not going to matter. So you look at this, you could write it out as 34,000 joules on top. Now the mass is in kilograms, so same thing here, that 1.65 kilograms, you need that to be in grams for the calculation. So again, 1 kilo anything is 1,000 of those things. So you could write it as 1.65 times 10 to the 3rd, or you could write 1,650. It doesn't matter, as long as you understand that it's 3 sig figs, although that is written as 3 sig figs in grams. And the change in temperature, well, this is your final and this is your initial, so it went from this to that. So you can subtract 73.62 minus 20.20, and then your delta T in degrees Celsius, which is fine because you're already in degrees Celsius, but a change in Celsius is equivalent to a change in Kelvin. So you do your subtraction from that, and you get 53.42 degrees Celsius. So you can do your calculation for this, and on top you have your 34,000 joules, and when you look at what you're going to divide that 34,000 by 1650, so divided by 1650, and then you're going to divide that by your change in temperature, which is 53.42, and you get your specific heat for copper in joules per gram degrees Celsius. You can only have 3 significant figures based on what you had there, so it looks like for your final answer you're going to have to report that as 0.3, I believe it's 0.386, and just double check my calculator. 0.3857, so yes, 0.386 joules per kilogram, or joules per gram degrees Celsius. And again, that would be one that you were not allowed, one plus or minus 1 on the last sig fig, just because on different questions I probably had, on different versions of the test, I probably had slightly different numbers, whereas that 0.386 might have been 0.387 or 0.385 or something like that on a different version. based on just slight differences in some of these numbers. But anyway, that should get you another way that you can practice using the specific heat formula, Q equals mc delta T, in this case solving for the specific heat itself. You could also expect that I give you questions. I could ask you just as easily about mass or something like that, or about an initial temperature. So just make sure that you can work that equation back and forth however you need to. For instance, this equation, the original equation, Q equals mc delta T, can be written as Q equals mc times the difference TF minus TI, like that. And if I ask you for a final temperature here, then you're going to have to rearrange the equation. So you'd have to have a Q divided by mc equals TF minus TI. And then if I want you to solve for a final temperature, then TF would equal the quantity Q over mc plus Ti, like that. And that would give you your final temperature. So just keep in mind that you need to be able to algebraically rearrange those as needed to solve for whatever kind of question you're presented with. But that'll give you, like I said, another example.